Hi, this video is on logarithmic differentiation, and logarithmic differentiation is important because when you're facing problems that would normally require product rule, quotient rule, and chain rule, doing logarithmic differentiation would just make it really easy. So first I'm going to start by introducing some log rules. So the first rule is the product rule, and that states that the natural log of a times b is the natural log of a plus the natural log of b. The second rule states the natural log of a over b, and this is the quotient rule, is the natural log of a minus the natural log of b. And the third rule is a power rule, and that states that the natural log of a to the n is n times the natural log of a. And now I'm going to introduce some differentiation rules. So the first one is that the derivative of ln of x equals 1 over x and x is greater than 0. The second rule is that the derivative of the natural log of u, and u is a function, is the derivative of that function over the function. And the third rule is that log base a of x is 1 over the natural log of a times x. And the fourth rule is the derivative of log base a to the u, and u is a function, is the derivative of that function all over the natural log of a times u. And then there's just some additional rules that are good to know. So the first one is that the derivative of a to the x is the natural log of a times a to the x. And the second rule is that the derivative of a to the u, and u is a function, is the natural log of a times a to the u times the derivative of that function. So now I'm going to do a practice problem. I'm going to show you how I apply these rules to do that problem. So the problem that we're going to do is y equals 5x minus 4 to the fourth all over 3x squared plus 5 to the fifth times 5x to the fourth minus 3 cubed. So first I'm going to take the natural log of both sides. So the natural log of y has to equal the natural log of 5x minus 4 to the fourth all over 3x squared plus 5 to the fifth times 5x to the fourth minus 3 to the third. So if you haven't noticed yet already, this is in the format of the log quotient rule that I said about earlier, where the natural log of a over b equals the natural log of a minus the natural log of b. So we're going to apply that here. So the natural log of y is going to equal the natural log of 5x minus 4 to the fourth minus, and I'm going to put brackets and I'll explain why in a second, the natural log of 3x squared plus 5 to the fifth plus, because we're doing quotient rule for the denominator, the natural log, not quotient rule, sorry, product rule, 5x to the fourth minus 3 to the third. So the reason I put brackets is because some people, when they're doing the product rule in the quotient rule, they forget about this negative and how it needs to be distributed to both. This negative needs to be distributed there. So I'm going to keep on going. And now we can apply the power rule, which is that the natural log of a to the n equals n times the natural log of a. So here n is 4, so it would be 4 times the natural log of 5x minus 4 minus 5 times the natural log of 3x squared plus 5 minus 3 times the natural log of 5x to the fourth minus 3. So now I've simplified it as best as I can with the log rule, so I'm going to go ahead and differentiate. So using this rule right here, we know that the derivative of a natural log of u is u derivative over u. So we can apply that same rule here. So the natural log of y is the derivative of y over y. And then using that same rule, natural log of 5x minus 4, it would be 5 over 5x minus 4, because 5 is the derivative of 5x minus 4, minus 5 times, and the derivative here is 6x over 3x squared plus 5, minus 3 times, and here it's 20x cubed over 5x to the fourth minus 3. So now we're going to multiply both sides by y so that we can get the y of the denominator here. So we get 20 over 5x minus 4 minus 30x over 3x squared plus 5 minus 60x cubed over 5x to the fourth minus 3, all times y, which is 5x minus 4 to the fourth over 3x squared plus 5 to the fifth times 5x to the fourth minus 3 to the third. And this is our answer. And you can do a common denominator for this part right here, but the reason I didn't do that is because there's 3 different denominators and that's going to get really messy, so I didn't do that. But usually if it's just 2 or it's simple like common denominator work, then I would recommend doing it because you'll see cancellation out in the numerator. But if it's something like this, it's best just to leave it like that. So I hope this video helped with that.